diversity of their recommendation. It will help with the longer term retention. And we're trying to push the state of the art in each of those, introducing new technologies, new capabilities, and bringing new experiences.
Go through checkout, tap your card, and there, you paid in less than 2 seconds. It's faster than, hold on, this, and safer than this. That quick exchange is thanks, in large part, to these. Just a few little wires that make contactless payments possible. Here's a look inside the tech that makes those payments both quick and secure, and why Tap to Pay has taken so long to gain traction in the US. This is the tech behind Tap to Pay. At the heart of Tap to Pay is a technology called NFC, or Near Field Communication, which itself is a specific form of RFID, or radio frequency identification. You might be familiar with it as a way to unlock your hotel room, for example. NFC relies on those little wires, which are actually antennas.
The antenna kind of looks like a racetrack, and it's sort of a coil of different wires. And that's what's used to basically transmit the radio frequency on both sides.
This is Mike McLennan. He's the general manager of hardware at Square. Maps expanded its tech quickly, opening it up to developers, integrating Street View, and launching Android and iOS apps early on. But how exactly did all of this come together to get you from point A to point B? Christopher Phillips, the current head of Google's Geo division, gave us an inside look on the Google campus.
The foundational piece was to have a real-world model, the digital truth of what's going on in the real world, including where streets are.
Let's take a look at a real route in San Francisco that Chris walked us through.
Let's say I'm in the San Francisco Ferry Building, the farmer's market, and I need to get to San Francisco International Airport.
To get that real-world model Chris was talking about, Google starts with satellite and aerial imagery to create an accurate map. This is layered together with data from Street View. To do this, they use a process called photogrammetry. Using this and GPS data, they can pinpoint the right coordinates for the image. If we take a quick detour off our route to France, you can see what the layering process looks like using the Arc de Triomphe.
Think of it as a big jigsaw puzzle where we can put these images together and we understand the distance between images and where they sit with the actual location, the GPS location.
Google keeps a range of the cameras that have been used over time to capture imagery at the Street View garage on its campus in California.
It all started with a 500-pound camera that was
forklift at the speed
onto
of
a
sound,
van.
right, which is 343 meters per second. If you think about that in terms of the thickness of an earbud, it's getting from the outside of the earbud to the inside of the earbud in about 15 microseconds. So that's millionths of a second. We're doing math as fast as we can to basically cancel it out before it gets in.
Because everyone's ears are differently shaped, active noise cancellation requires algorithms that can be tuned based on the user. Bose, for instance, does this by playing a welcome chime and monitoring feedback from the internal microphone to customize noise-canceling filters accordingly. This requires a lot of testing to make sure the algorithms work on a wide range of users in all types of noisy environments. But eliminating background noise is just the first step. The next is figuring out what noise to remove, based on the context.
I think it's really important to recognize that noise is not bad. Noise is critical to my brain, critical to my body. My brain uses it to create richer experiences, to fill in what's missing, which is all the time.
Poppy Crum was previously the chief scientist at Dolby Laboratories, where she worked for more than a decade. His team started shooting on this camera, or rather, cameras.
When I first showed up, it was 11 Reds welded together in a kind of Frankenstein.
But combining the views from those 11 cameras made it difficult to shoot and edit.
So that led us to design the Big Sky camera system, as well as the lens system, to take all those different perspectives on the 11 different lenses, but make it one perspective so it feels like your eyes work.
This is Dinan De Silva, chief architect of the Big Sky camera. He walked us through Sphere's camera lab in California.
That's amazing to have a tool which is so sensitive and be that versatile with it is really just an amazing tool to have.
Filming content for Sphere has two big challenges. It needs a camera that can shoot at a very wide angle and at a super high resolution. To get that super wide angle, Big Sky uses a giant version of a fisheye lens, almost a foot in diameter. It makes a circulinear image, which distorts the view in order to capture a wider angle in a circle. Then, as light passes through the lens, it imprints itself on a sensor, which breaks it into tiny squares of color called pixels. Larger pixels allow the camera to capture more light and more detail. So to capture a higher amount of large pixels for a screen the size of the sphere, you need a bigger sensor than a screen the size of, say, your phone. Some of those pixels are wasted on a normal rectangular sensor, since a circle doesn't take up the full frame. But
that circle captured from that lens is projected onto the sensor in a circular format, and that circle fits perfectly in a square.
Charts and early streaming platforms like Pandora and Last.fm.
With the Last.fm app from the App Store, you can listen to great bands.
So when Spotify entered the scene in 2008,
it's not so much that they were the first people to start using analytics to recommend music, but it was the way in which they combined various computational techniques in order to make their recommendations feel more lifelike.
Thomas Hodgson studies algorithms and artificial intelligence with a focus on how new technology from music streaming companies impact artists.
Fans who listen to Discover Weekly and Daily Mix, the way that they talk about them is in very human-like terms.
Discover Weekly, you magnificent. You've done it again.
In 2014, Spotify acquired music analytics firm The Echo Nest, which blended machine learning and natural language processing to build a database of songs and artists. Spotify says this technology marked an important step in the evolution of its recommendation system. So how does that system work? It starts with a process called collaborative filtering.
Collaborative filtering looks at the pattern across all of this data and tries to understand when do tracks happen to be playlisted together very often. You can think of it as building a map of music and podcasts.
That map looks something like this. Each point represents a different track in Spotify's catalog, and the location of each point is determined by collaborative filtering. Many factors before making a recommendation. Some industry experts also point to issues with how the system understands metadata for classical music. For example, the metadata for a Tchaikovsky track can include not just the name of the work and the artist, but also the movement, opus number, and conductor. Spotify's algorithm isn't optimized for that. Apple Music, which has emerged in recent years as a competitor to Spotify, released a new app in March that the company says is designed to solve this problem. Spotify says it doesn't comment on a competitor's marketing campaigns. In February, the streaming service joined the recent buzz around generative AI.
I'm X, and from this moment on, I'm going to be your own personal AI DJ on Spotify.
The DJ gives the algorithm a human voice and offers listeners additional context around a recommendation.
Up next, I know you've been on a summer song kick lately.
Sultan says the company is also exploring reinforcement learning, a technique that would allow the recommendation system to learn automatically based on feedback.
Go away. So they still want to hear some things, they don't want to hear other things. And can you just give me a set of headphones that, just cancels the stuff I don't want to hear? That's not a thing that we're offering yet, but that's the kind of thing that is being worked on.
In July, the Sphere switched on for the first time, dominating the Las Vegas skyline.
Oh, I don't think it likes it.
But inside the 366-foot-tall dome,
we are not outside. Is that incredible?
Is an even more incredible, immersive experience. The dome holds the world's largest high-definition screen, 160,000 square feet, nearly 20 times the size of the largest IMAX screen. But the screen is just one piece of groundbreaking technology made for this venue. To create content for the screen, Sphere needed a new camera to shoot it. This is the tech behind the Sphere. When director Darren Aronofsky set out to make Postcard from Earth, a movie exclusive to the Sphere, featuring immersive scenes from all around.
And if I sum those two things together, I'll be left with a flat line. I'll be left with zero pressure, and that will be interpreted by my brain as the noise having been canceled.
Bose was the first company to develop noise reduction technology for headphones.
Dr. Bose was coming back on an overseas flight and got very frustrated by the fact that airplanes were very noisy. We can control all sorts of other stuff. Why can't we control noise? The first application that we looked at was canceling noise on airplanes.
Pilots wore its earliest prototypes in 1986. While the technology has gotten more sophisticated, the basic science remains the same. Active noise cancellation requires a few main components: an outer microphone to track incoming noise, an inner microphone that tracks sound waves that make it inside your ear and also checks if more environmental noise than expected is making it through, a digital signal processor to run some algorithms based on data from the mics, and the speaker, which cancels the background noise while also playing the music or sound you want to hear.
Think about how fast this has to happen.
Say that this is also more secure than other ways you can use your card. Unlike swiping, your static data is better protected during that communication. And because it doesn't have contact with the reader, it's not susceptible to malware that can affect chip insert transactions on rare occasions. This tap-to-pay technology has taken off in the last few years, in part because of the push for contactless during the pandemic. Square says such payments tripled between the beginning of 2020 and the end of 2022. While other countries, like the UK, have had contactless integrated into public transportation for years, it's taken the US more than a decade to get here.
For a whole new way to pay, MasterCard introduces PayPass.
The US first started issuing tap-to-pay cards in the 2000s.
Peter Rudiger is a Wall Street Journal reporter who covers payments and financial technology.
Different banks thought it was a cool new technology and thought their consumers would really flock to it. Didn't really work out just because there were few businesses that were set up to accept tap-to-pay.
US retailers have been slow to replace payment systems, in part because they're expensive to change. In 2022, about 55% of merchants said they accepted tap-to-pay, with others saying they were planning on implementing it. Consumer behaviors are also difficult to change, and the switch to contactless didn't feel urgent.
It's just often been described as a solution in search of a problem. Yes, it might be convenient, and yes, it might be safe, but that's not usually enough for people to switch their behavior.
The tech still has room to grow, and the push to integrate it. Google says the future of maps aims to be more comprehensive and immersive.
We're taking technology where we can combine and fuse together satellite imagery, aerial imagery, street view imagery, user contribution to create a photorealistic view of what it might feel like to check out a park. What's the vibe of it? What's the vibe of it on a different day?
Immersive View is Google's next step in using their database of information and imagery to map the world.
If you go to a big arena concert, like Taylor Swift's Eras Tour, or watch your basketball team score a buzzer-beating three-pointer in the playoffs, or attend a K-pop show, light-up sticks and wristbands will likely be a part of the experience, turning the audience into part of the show, with synchronized light displays at the touch of a button. So how do these small devices create these huge immersive visuals?
It's funny because oftentimes people think like there's a GPS in each of the devices, or like there's a lot of like AI advanced technology, but we really like the old school technology and just be creative with it, you know?
This is the tech behind LED wristbands.
Montreal-based is working in its favor. In New York, for example, subway riders can now tap to pay at turnstiles.
So you have this big push to get tap-to-pay into more transportation systems and to get people used to using it, every day. And if you're going to use tap-to-pay to get on and off the subway at least twice a day, maybe you'll also use it for your coffee, your lunch, your drinks. At least that's the idea that the credit card companies hope happens.
Square and other companies have also recently released the functionality to use the NFC antenna in your phone as the active connection, essentially putting a reader in your pocket, which could make it easier for small retailers to accept card payments.
This is showing you where it wants you to tap, and so the NFC antenna on your phone is right behind this. And so when I take my NFC-enabled credit card and I hold it over there, done. Transaction complete.
Here's a sound wave, and here's its inverse.